Hi all, in today's video we're going to be going over the progress check solutions for the first progress check that we've done on Monday. Okay, so the first question, Gaussian elimination, and given these equations we have to solve for x, y and z. Okay, so when marking this everyone knew this went into an augmented matrix. Okay, so I'll just do that as well. So the matrix is we've got 1x, 1y, 1z, and that equals 10 in the first row. We've got 2 x's minus a y and 3 z's, and that equals 4 in the second row. And we've got 1 x, no y's, and 2 z's on the last row, and that equals 20. Okay, so that is my aim, okay, is to solve this augmented matrix. Okay, how we do this is we look for zeros, okay, so we look to try and get zeros in this lower ELF position here. Okay, and that's my aim, because if I can do that, I can then solve one equation at a time to then find the next variable. Okay, so how I'm going to do this, okay, well, in order to get a 0 in this bottom left corner, okay, so in row 3, what I'm going to do is I'm going to do row 3, oh, let's try that again, it doesn't look like row 3 to me, so let's try that again. I'm going to do row 3, take away row 1, okay, and that is going to give me a 0 in there as well. Okay, I'm also going to try and find a 0 in the row 2, in the first entry in row 2 there. So how I'm going to do that is row 2, that's going to be row 2, take away 2 lots of row 1. Okay, I'm always going to use row 1 here because it's got a 1 in the top corner, makes it very nice and easy to try and get zeros here. Okay, so I'm going to focus on these two zeros first. I'm not going to do this one, okay, that'll come later. Okay, so this might change before I make it back into a 0. Okay, so doing that, okay, if we take it nice and steady, now it's very easy to make errors in these, okay, very quickly. So if we just take our time with these, well, nothing's changing in row 1. Okay, so nothing's changing there. Right, row 2, I said I had to do 2 lots of row 1 and take it off of my answer for row 2. Okay, so I've got 2, take away 2 lots of 1. That's going to give me 0 there. Okay, that's ideal, so I wanted. I've got negative 1, take away 2 lots of 1. Okay, so 2 lots of 1 is 2, so negative 1, take away 2, that gives me negative 3. Okay, I've got 3, take away 2 lots of 1, that's 3 take away 2, which is 1 there. And 4 take away 2 lots of 10, which is take away 20, which is negative 16. Okay, so that's what my second row should become. So if you got that, you've got a mark. Okay, right, row 3, bit nicer actually, it's just row 3 take away row 1. So 1 take away 1 is 0, that's good, got a 0 there. 0 take away 1, that's negative 1. 2 take away 1 is 1. And 20 take away 10 is 10. Okay, so that is now my new matrix. Okay, right, I still want to get a 0 in this position here, so that is going to have to change. Okay, so how I'm going to do that? Well, I'm going to use row 2 against it because I've got zeros in both the first entries now, and they're going to hit off each other, which will keep them as zeros, which is good. Okay, so I've got negative 1, I need to try and make that a 0. I've got to bounce it off negative 3. Okay, so what I can do is I can do 3 lots of row 3. Okay, so that I can make that into a negative 3, and then I'll take off row 2. So that'll be take away negative 3, which will then give me back to 0. Okay, so that's how I'm going to solve that augmented matrix there. Okay, I'm going to do 3 lots of row 3, subtract row 2. Okay, so if I am doing that, okay, then I'm going to 1 there. That row stays the same, so that's 1, 1, 1 and 10. Now second row stays the same now, because we solved for the 0 there, that's fine. Right, this last row will 0 take away, sorry, 3 lots of 0 take away 0, 0, that's good, keep it at 0. I know I'm going to get 0 in the second position now. 3 lots of 1 is 3, take away a 1, that gives me 2, so I got 2 there. 3 lots of 10 is 30, okay, 30, take away negative 16, okay, which is the same as add 16, that gives me 46. Okay, so that is my matrix, and now I'm ready to solve. So what row 3 says is that 2 lots of z equals 46. Okay, therefore z equals 23. Okay, so I found my z. I can then go to row 2. Row 2 says negative 3 lots of y plus a z equals negative 16. So that equals negative 3y plus a 2 equals negative 16. Negative 3y, Sorry, not a 2, my apologies, made a silly error there. Let's try and fix that. Plus 23, I should say, equals negative 16. So if I take the 23 over the other side, I get negative 39. Therefore, my y, if the negatives cancel on both sides, divide that by 3, I'm going to get y equals 13. Okay, so that's my second variable found. I'm now going to use row 1. Okay, so row 1, that's going to be an x plus a y plus a z, that equals 10. So x plus y, that's 13, z is 23 equals 10, so that becomes x plus 36 equals 10. Take off the 36, I get x equals negative 26. Okay, so how I'd write this as a final solution. Okay, so that's your 5 marks all there. Okay, for getting those answers there. Something neat to do, make a wee box, just so that somebody marking it can easily find your answers. Okay, you don't get any extra marks for this, but it is quite a nice wee step to do. Okay, so that was the answers to question 1. Okay, so just a bit of hindsight. Okay, be very careful with your numbers, okay, and be very careful. A lot of people managed to get the first 2 rows, okay. This one here did cause a bit of difficulty, so just be careful with your numbers, okay. Okay, we'll go down to question 2. So write down and simplify the general term in expansion bracket 2x minus 1 over x squared to the power 9. Hence or otherwise obtain the term independent of x. Okay, so there's 2 steps to this. Okay, so we'll find the general term first and then work out what the term that wouldn't have an x look like. Okay, so first thing to note, okay, is that n is 9. Okay, now the general term actually comes from the formula that is actually written on your sheet. Okay, so you'll see the binomial expansion has got the sum of. The general term is just without the sum, it's the notation, so it's going to be n choose r. Then it's going to be the first term, so it's 2x for us, to the power n minus r. Then it's the second term. Now be careful because that is a negative in front of the 1 over x squared. Okay, so we need to include that, that's going to be important for us, and to the power r. Okay, so that's what the general term starts as. We start filling it in. Okay, so 9 choose r, I can swap all the n's for 9s. Okay, so that's 2x 9 minus r. I'm just going to rewrite this so it's negative x to the negative 2r there. Okay, so I'll just use my skills from higher to change that there. Right, okay, now I want to get all the numbers to the front and the letters to the end. Okay, so I've got 9 choose r, that will be a number, whatever r is. I've got a 2 in here, so that's going to be 2 to the power 9 minus r. I actually do have a number in front of here and it's negative 1. Now it might not seem very important that, but trust me, that will be important because depending what r is means if this thing will be positive or negative or not, okay? If this is odd, if r is odd, then this is going to keep this function negative. If it's even, negative 1 squared or negative 1 to the power 4 becomes positive and that will change it to a positive term. Okay, so that is important there, okay? Then I've got my x term, so it's x to the power 9 minus r. And then I've got my other x term, x to the power negative 2, all to the power negative r. Okay, so my numbers are fine. Okay, I just need to combine my letters now, so it's going to be 2 to the power 9 minus r minus 1r. Okay, right, combine my x's. Okay, so first thing to do is I'm going to note, just to help me with this, this bit here becomes x to the power negative 2r. Okay, remember you multiply your powers when it's like that. Okay, that's laws of indices. So when we have got x's here and x here, when we multiply them, we add the powers. So it's going to be 9 minus r plus another negative 2r. That's going to be x to the power 9 minus 3r there. Okay, so that's what the general term looks like. Okay, to work out the term independent of x. Okay, so independent of x. That means we need x to the power 0, which means we need 9 minus 3r to equal 0. Therefore, if we solve that, quite easy to solve, r has to be 3 there. Okay, so what the term independent of x is when r is 3. So when we make r equal to 3, the general term becomes 9 choose 3. 2 to the power, well 9 minus r is 2 to the power 6. then it's minus 1 to the power 3. Now you'll see that's important because we do keep this negative because of that there, okay? Put that all in your calculator and you get the answer negative 5,376, okay? So you get 3 marks for getting your general term, okay? Then your 4th mark is working out what the value of R should be, and the last mark is for getting your value. Okay folks, so there is the solution for question 2. Okay, so we're going to differentiate for question 3. Okay, so the first thing is we've got a product rule, so I've got u is x to the power 6 and v is cot 5x. Okay, so you'll need your formula sheet for this. Differentiate them both, I get 6x to the power 5, no problem there. Differentiate this, well cot becomes negative cos x squared, okay, but remember the 5 does come down to the front like it would if it was sine or cos, okay, so I'm going to get 5 negative because it's negative cosec this becomes, so it's negative cosec squared 5x. Okay, so that's my u dash and my v dash function. Okay, so remember notation, so I'm working out the differential, so that's going to be u v dashed plus v u dashed. U v dashed, okay, that's going to be negative 5 lots of x to the power 6 cosec squared 5x plus v times u, that's going to be 6x to the power 5 cot to the power 5x. Okay, you actually get 2 marks for that, 1 mark for each term. However, to make your answer a bit nicer, okay, and be careful because you can lose marks at this stage here though, okay, however it should be within our skills to take out common factors if we see any. Okay, so we can take out x to the power 5 in both. That would give me, now if I start with this one it'll stay positive, so it'll be 6 cot 5x minus 5x lots of cosec squared x. Okay, oh 5x, sorry, that should be. Okay folks, so that's how we get that one done. So quite a quick question if we remember the product rule. Right, and the last question. Okay, so on a suitable domain, a function is defined by f of x equals e to the x squared minus 1. Okay, now be careful, that minus 1 is part of the power. Okay, and x squared minus 1. So we've got a quotient rule. Okay, so I still need to work out what my u and my v are. So that's going to be e to the x squared minus 1. V is x squared minus 1. Differentiate them both. Now when you differentiate an exponential, you differentiate the power, and that comes down to the front. So the differential power there will give me 2x. Then the rest stays the same. And if I differentiate that, I get 2x there. Okay, so that's my data. Okay, so f dashed x, that's going to be v u dashed minus u v dashed all over v squared. Please make sure we get the formula right in that one, folks. Right, v times u dashed. Okay, so that's going to give me 2x e to the x squared minus 1 lots of x squared minus 1. Okay, take away u times v dashed, that's going to give me 2x e to the x squared minus 1, all divided by v squared, which is going to be x squared minus 1 squared. Okay, so that's what my differential looks like. I get 1 mark for this first part here, 2nd mark for completing that. Okay, the 3rd mark comes from can we simplify our expression. So let's see if we can work this out. If I multiply out these brackets here, I'm going to get 2x e to the x squared times by x squared, so that's going to be on top of that x there, so that's going to be cubed. Okay, then I've got minus 1 lot of it, so it's minus 2x e to the x squared minus 1. Take away 2x e to the x squared minus 1. Oh, it should be an x there. Okay, all over x squared minus 1, all squared. Okay, now the last 2 terms in the numerator I can combine, so that gives me 2x cubed e to the power x squared minus 1. Take away 4x e to the x squared minus 1. Okay, still all divided by x squared minus 1 squared. Okay, and now what I can do, just to finish off, is to take a common factor. Okay, so I can take a 2 out of them both, I can take an x out of them both, and I can take an ex squared minus 1 out of the power of both. Okay, so what I have left in the first term is x squared. Okay, because I took out 2x, still got x squared there. And what I have left there, well, the only thing that I have left is if I did 4 divided by 2, because I took the 2 out, would give me 2 there. Okay, and I've got x squared minus 1 squared there. So the denominator I couldn't simplify, but I could simplify my numerator and take a common factor out. Okay folks, so that's the solution to progress check number 1. Okay, I think looking at the results from the first test, I think we'll give another Gaussian elimination question in the next one. However, we will try some alternative differentiation questions, and we might change the topic to something else as opposed to binomial expansion. Okay folks, thanks for listening.